Let's focus on the reductions for 180 degrees minus theta. That is for an angle formed between 90 and 180 degrees, so in the second quadrant. But before we can move on to explain the reduction formula that takes place in the second quadrant, let us quickly revise what we already know about the trig ratios. So if theta is an angle in the first quadrant and we take that line and create a right angle triangle, we know that the trig ratios can be found in that triangle. So that means that sine theta is y over r, cos theta is the adjacent over the hypotenuse, and tan theta is the opposite over the adjacent. Now let's apply that same principle when the angle is formed in the second quadrant. So in the second quadrant, this angle that is formed is known as 180 degrees minus theta. So what we are saying is we can go a full 180 degrees and go backwards by theta. And if we plot this point and create a right-angled triangle, we can name this point R prime, where the hypotenuse would be R because R represents a radius. Remember in the previous video we spoke about this line representing a radius. That is a circle right around, and all that we are doing now is we are taking that line and going a bit further in our circle. And if we look on our x value, we can see that it is on the negative side of the Cartesian plane. So this x value would be a negative value. And our y value for the r coordinate would be a positive y value, which is the same as the y value in our first diagram. So now I can find the three trig ratios for 180 degrees minus theta. I still apply the same rules, but my angle now is on the outside of my triangle. So y would be opposite the angle, negative x would be adjacent to the angle, and r would still represent the hypotenuse. So sine of 180 degrees minus theta would be the opposite divided by the hypotenuse. So that will be y over r. But notice that's the same as sine in the first quadrant, which is also y over r. So we can conclude that sine of 180 degrees minus theta is equal to sine theta. And cosine of 180 degrees minus theta is the length of the adjacent side divided by the hypotenuse. So it is negative x over r. So if we compare it to the first quadrant, which is x over r, we see that we now have negative x over r, and that leads to negative cosine of theta. And the tangent of 180 degrees minus theta is y over negative x. And if we simplify that, we can see that that is equal to the negative of the tangent of theta, because the tangent of theta is y over x. But this can all be a little intimidating, so it helps to remember these values in terms of the Cartesian plane. We know that in the first quadrant, all of the trig ratios are positive, and in the second quadrant, only sine is positive. And we also discovered that 180 degrees minus theta is somewhere in the second quadrant. So we can conclude that only the sine of 180 degrees minus theta would be positive in the second quadrant. The cosine and tangent of theta would both be negative in that quadrant. So to summarize, sine of 180 minus theta is equal to the sine of theta, and it is a positive value. The cosine and tangent of 180 degrees minus theta are both negative in the second quadrant.